Okay, now that you've watched the video on how to find lateral surface area, and volume of a pyramid, let's do some examples and just make sure that you can really become a pro at this, okay? So I also have my trusty assistant here, Sawyer.
Hello.
Right? And to help us out with this, okay? Okay, so we take a look at this one right here, and it says the directions. Find the net, volume, lateral surface area, and surface area for each right square pyramid. Okay, so if I'm taking a look at this one, if I'm going to think about unpeeling it and thinking about what it's going to look like, right, I think to myself and I say, okay, right, we did a pyramid before, right, so can you grab the net for me in that, okay, and, you know, I have a square base, okay, and, yep, there we go, and then this is going to be basically what it looks like for me when it gets unrolled, okay, that we're going to have triangles, and that triangle right there matches up with that triangle, right, and then all the triangles are going to be peeled back, right, to make a whole bunch of triangles. Whoops. Okay, it may not look like it, but they're all supposed to be congruent. Sorry for bad drawing there. Okay, so if we look at the square has, it tells me it's a square. Remember, it says right here it's a square, so that's how I know that this is 6 over here as well. So we have 6, 6, 6, 6 all around there, okay? And so we can easily find the area of this is 36, and that's going to help us for the surface area, does not help us for the lateral surface area. If we're looking at the lateral surface area, I'm going to take my highlighter out. Excuse me, Sawyer. Let me get my highlighter. I'm going to highlight one of these triangles. I'm going to highlight this one that's on top. Okay? And for that, I can see that the base is 6. I just need the height of it. So I have to look back at this, right? And it might help to kind of put the shape back together here like this. Let me zoom out so we can kind of see the shape back together. Okay? Notice as we're looking at that shape, right, that the 4, let me turn so you can see, the 4 is the actual height, and the 5 is was actually on the side. So that's why we're going to use the 5 here. The 5 is our slant height for ourselves. Okay, the 4 is inside of it. It's inside. So if we looked at this, right, there's the 4. Yes, sir. A question for me.
So would it help if people knew this part?
No, we don't need that one because that's not the height of the triangle. That's just, again, that slant edge. That's the same question Sawyer asked in the earlier part.
So you don't need to use this to figure out the problem?
Not at all. You're not going to need that at all. It's just kind of there. I'm not going to label it on these diagrams, so you don't really have to worry about it. Okay, so let's do our lateral surface area. We can see that there's 4 triangles, so I'm just going to multiply by 4. And each triangle is 1/2. Base is 6. Height is 5, right? Oh, Sawyer's getting a call. All right, Mr. Popularity. All right, so we get so we get 60, right? 1/2 times 4 times 1/2 is 2 times 6 is 12 times 5 is 60. Okay, and there's no units there, so we'll just leave it as 60. Our surface area is the LSA plus the area of the base. Remember, there's only one base, so we're going to do 60 plus 36. So we get 96. And we do volume. We remember from the video, area of the base times height divided by 3 because 3 pyramids fit into a prism. Right? Area of the base is 36. We already found that. Height. Remember, it's the regular height. Right? The regular height for ourselves. So that would be, whoops, that'll come off. Right? That would be that right there. That's the regular height for me. Right there. Okay? Not the slant height. Right? And so it's going to be 4. 36 divided by 3 is 12, times 4 is 48, and now we have our 3 answers, and there's our net. Okay? Now, we look at this next one, and you say, okay, I'm going to draw my net. My net, there's the square base. Right, here are my triangles. I'll try to do a better job this time of making all the triangles look congruent to each other, because they are. The triangles are congruent because the base edges are all 10, because it's a square. Again, directions say square base pyramid. Okay, and so I just need the height of that triangle. Let me highlight that triangle I'm talking about right there. And here's that triangle right on this, okay? Right, on here, you could be talking about this triangle right here, okay? And if we're looking at the height of that triangle, right, for ourselves, you can see that 12 is not the height of the triangle, 12 is the height on the inside, right? Actually, I should have highlighted a different triangle. I should have highlighted new one, right? Okay. Nope, I got it. Thank you, sir. I should have really been highlighting this one because it's probably easier to see if we do this triangle right here. Okay? And if we look at that triangle, we can see that the height of it is right here. there's the slant height of that triangle. Okay? And if you connect it with the, on the bottom, you can see you have 12 here, and we have this length here. Now, how long is that length? This whole thing's 10, and that's in the center. So if that whole thing's 10 and that's in the center, then that must be 5. So we can use Pythag to get that. Or, if it's even better, look at that triangle. It's got a 5, a 12. Hey, 13 is the missing length there. Okay? So we're going to use Pythagorean theorem or a triple. We're not going to have to use specials. Right? That's not going to come up for these. Okay? So that's going to be 13 there. Right? That's the slant height. So the area of each triangle is 1/2 base times height. Again, 4 triangles. So that's going to be my lateral surface area. Okay, so that's going to give me, I'm going to do it this way. I'm going to cut that in half. That's going to be 260. And then my surface area, take that 260, that LSA, add the area of the base, which is 100. So it gives me 360. And for volume, area of the base, 100, times the height. 12 is the height, not 13. 12 is the height. So I get 400. Okay? So those are a couple of examples there. So, right, you should be taking notes along with me on this paper here, right? So let's look at example 2. All right, find the volume of the right regular hexagonal pyramid. Okay, so we're going to find volume, and remember that pyramid volume, right? When you're doing volume, it's always area of the base times height divided by 3. Okay. So what's the height? Oh, I can see the height is 12. So that's at least, I'll put that in there. But I need to do the area of the base. Let me draw out what that base looks like. It says it's a hexagon, so let me draw the hexagon. Okay, and look, it says the sides are 8. So I need to find the area of that hexagon. Okay, well, we just did that in the last unit. We found area of hexagons. We can do that now. Area of the hexagon, okay, right? When I have a hexagon, this angle is 60 and this is 30. So that's 4 and that's 4. So 30, 60, 90 says that's 4√3. So the area, right? We don't need that. Thank you. All right. 8 times 4√3. Okay. So it's going to give me 16√3. But there's 6 triangles, so it gives you 96√3. So all of this is review of what we did in the last area unit. Okay, this is find the area of the hexagon. And in theory, we could do this with other shapes like pentagons and octagons. But if we're doing those shapes, you have to use trig. So we're just going to focus on the hexagon more so because, and then the, yeah, just the hexagons here. Okay, so that's going to give me 96√3. Okay. So we're going to do 96 times 4, right? Put that in your calculator in case you can't do it in your head. And you get 384√3, no units, so there's our volume. Okay. Notice I didn't find the surface area because the problem didn't tell me to find the surface area. Okay. What about example 3 here? Find the volume of the oblique square pyramid. Hey, it's still a pyramid and we're still doing volume. So the volume equals the area of the base times the height divided by 3. Okay. It says that we have a square as the base, so it's 8 by 8. So that base area is 64. What's the height? The height just happens to be on the outside, so it's over here, so it's going to be 14. But it's okay, it's on the outside. It's still how tall it's going to be. So you just look for, something coming from the vertex straight down. Okay? We put that into our calculator, right? I can't do that one. I'm actually going to need a calculator for that one. 64, I got it. Thank you. 64 times 14. It doesn't divide by 3. It gives you a decimal that goes on forever and ever. I'm just going to leave it as 896/3 is my answer. There's no units, so I leave it that way. Okay. For example 4, find the volume of the right regular pyramid. Right rectangular pyramid. It's still finding volume. So it's still area of the base times height divided by 3. Area of the base, well, the base in this case is a rectangle. What's the dimension of the rectangles? 8 by 4. So the area of the base is 32. What's our height? 3. 32. Oh, look at that. Those can just cancel. Good. So it's just 32 is my volume. And that's all we have to do there. Okay? All right? So use those examples to help you do the rest of these. Okay? And they're going to be more just like that. Right? After you do these examples, right? Check your answers online, scan it in, upload it to Google Classroom for me, and then try the worksheet problems. Thanks a lot.